Hello, I'm JW, and continuing in the CNC build series, and today we're going to have a look at the control cabinet just behind me there. And I've actually wired in the mains power, the power supplies, the 48 volt and the 24 volt, and also the emergency stop circuit as well. So let's have a look. Now here's the front of the cabinet, and I've put a couple of buttons here which we'll look at in a moment. Here's the insides. And essentially we've got all of the wiring in position, so from all the things on the back plate essentially, and the fan on the side here and everything else. And I've got a few bits in here, these are not connected yet, just did that to confirm the voltages on these were correct before attaching them to these devices here. This will be connected to the thing in the middle later on, but pretty much the rest of it is sort of operational and functioning correctly. And I've put these two switches here in the front, just on the back of the panel here. And again, those are wired in as well. Now I'm just going to close that up and I'll show you how this does actually operate. Here we've got two plugs which go into the side of the machine there. One there, and of course the other one just next to that. And the cables go up here in the side. Now these are both obviously mains power going in. However, these two do not connect together inside the machine, so this means that if one of these was unplugged and that was turned on, you do not get an electric shock off of these pins here, and conversely the other way around, because obviously that would be extremely dangerous. So although there's two mains leads going in, they're totally separate with inside, so no particular danger in that regard. So got our switch here, which of course turns the thing on and off. Now if we turn on here, nothing happens to start with because the switch is in the off position. And if we turn this on, then what we can hear there is the fans in the side here, which are just basically cooling the entire cabinet. And that's pretty much all that's on at the moment. And the computer on the top here would be on if we actually switched it on. You can see the little thing blinking away there. So in this state, essentially all we've got is the fans running from the 24 volt supply, and also the socket on the side here for the computer on the top. I'm not going to turn that on at the moment because I don't actually need that. Now at the moment the emergency stop is pressed in, and these buttons here do absolutely nothing. And if we turn the button here to reset, then we'll see that this light here will come on which says e-stop reset, which means it has obviously been reset. And if we press it again, it will go out. But in this condition, pressing either still doesn't do anything. Now to actually start the other side of the thing, which is the 48 power supply and also the motor inverter, we need to press both of these, and if you press both of these, this light here will come on. You may have heard the contactor click in there, and then the inverter will now start, which has its own fan inside. So that's the inverter switching on there, and once it's on again, these buttons don't do anything because it's already on and operating. So that now, if the motor things were connected, it would be in a fully operational state, and therefore we could obviously cut things and move the axes around and so on. Now in the event of some major failure occurring, we needed to press the emergency stop here, then both of these will go out, and that's basically cut power to the 48 volt supply and also the inverter drive as well. Now there's a slight delay on the inverter. That's now switched off, but essentially pressing that will just cut the power regardless. And then again, if we reset this here, again, the light comes on, and then by pressing both we could restart it. And if you start it with the light not on and it's reset, well again, nothing will happen. And again, if we turn off here, then again that switches off the entire thing. The fun thing about this as well is if the power had been just turned off here, or say these were turned off at the switch here, and the motor was running, it would also cause the contactor to disconnect. And again, when it turns on again, it will be back in the completely off state. Now, of course, that could be left like that, and then if it's turned on like that, then the light will come on straight away. But again, the main motor and things will not start unless you specifically press both of these buttons to actually get it going. Now I'm just going to unplug these so we can have a look inside the cabinet. So just open that up again, and as I saw in the previous video, it's necessary to actually turn this to the off position. So if that was in the on position, you can't actually open the thing, but in the off position, of course, it opens perfectly well. Now I'm going to have a quick look around inside the cabinet, and then I'll do a more detailed demonstration of where the wires and things actually go. So on the side here we've got these two leads coming in. These are the mains power from those two plugs at the bottom there. So both coming in completely separate. The earth wires here, the green and yellow, actually come across to this earthing point here. So both of those go to that. And then the two wires here, the line and neutral and the blue and brown, go across here up the side, and they actually go across the top of the cabinet and come down to the back panel, which we'll look at in a moment. On this side here, these green ones are the earth wires from the various bits on the back panel, and again they all go to this central earthing point here. 48 volt DC from the 48 volt DC supply here, those just come across and to the actual motor drives on the front panel here. This is the 24 volt power supply, and again we've got wires coming off the bottom here for the fans on the side, and of course additional ones for things on the back panel, and also some more which come across to the front panel as well. Contactor in the middle here, and again the motor inverter there. And the purple and orange wires are basically mains power, so we've got mains power going in the bottom of this one, this actually goes in at the top, and again we've got the switch in the middle here and the inverter drive in the middle there. Now on the back of the front panel here, I've got the emergency stop here. I've just wired the two wires to this for the moment. There will be some more of these outside the cabinet, but just put the one in for the moment, as the others haven't actually been installed yet. 24 volts here from the power supply at the back, so again this we use to go across to various things when it's completed. And then just over here we've got the back of those two switches, which again some connections between, and also one coming across to the 24 volts. And then two more wires here which go back to the contactor on the back panel. And then these here are the motor drives, and essentially these connectors here will just go directly into those, four of those. And the wires for those do actually go back all the way to the power supply, so we don't have them sort of looping from one to the other. They all go back to that main power supply at the back. And I put these just on the end here temporarily so that I can check the voltages here are actually correct. Obviously shoving the wrong voltage into things like that is a sure way to destroy them. And I have actually checked these, and yes, these are all 48 volts, 24 volts here, and all of these other things do work correctly, as we've already seen. Now here's the back of the cabinet, and just a quick overview of where the wires actually go. Now on the left side here, just highlighted in red there, we've got the two main supplies coming in, and again these are completely separate. And they come from those two mains leads and then just go vertically up the side of the cabinet. They then continue across the top there and basically come down into the switch, which you can see in the centre. Now one of these goes to each side of the switch, and here we've got the right hand side pair, and again all these are switched on and off simultaneously, but crucially they don't actually connect together once they're inside the machine. So this right hand side pair actually comes straight through the switch, and it actually goes to the power supply for the 24 volts, and we see that highlighted in red on the left side there, and it also goes to the outlet sockets for the computer, and those are across on the right hand side in the panel. So in this state all we have powered is the computer and monitor, which are on the top of the cabinet from those sockets on the side there, and the 24 volt power supply. Now the 24 volt power supply powers those two fans, see over on the left side there, so those basically switch on whenever the main switch is turned to the on position. And additionally we've got other wires with the 24 volts going to the switches on the front panel, and those are also what's used to activate the contactor in the middle and various other things. So those things will be powered sort of by default, but crucially the 48 volt power supply for the stepper motors and the spindle inverter are not powered. So of course those things won't actually do anything unless we specifically actually switch them on and then require them to do things. Now the second mains inlet, which is the one on the left side of the main switch there, again comes through the same switch, so the whole lot is switched simultaneously if you want to turn off the whole power. Now those actually come through the switch, but they actually go straight into the contactor, which is just situated below the switch, and the left two contacts are used, so basically it's line and neutral in at the top, and then line and neutral out at the bottom. So anything that's powered on this side is only on when the contactor is on, and again that's one we have to actually specifically request to be switched on. It's certainly not going to switch on by default or accidentally. And the things that the contactor powers are the 48 volt power supply, see over there on the left, and of course the spindle inverter, that's located there on the right, and both those go via the contactor contacts on the left. Here's a closer view of the switch and the contactor. So see, it's just the line of neutral in at the top, and then another line of neutral on the right hand side. And we've got line of neutral out at the bottom. The left pair goes straight into the top of the contactor, and then the right hand pair actually goes directly to the power supply in the middle and the computer sockets over on the right. Now here's the actual contactor itself, and this has 4 poles, so marked there in the sort of L1, L2, L3 and then 13 on the right. This is designed for 3-phase, but we're only using it for single phase, and I've actually coloured in the front there with various colours to match the wires that come in. So mains power is only on these first 2 contacts, sort of 1 and 2, so line and neutral, and then that's what goes through to the bottom when the thing is actually switched on. So basically it's just a switch, it just turns those on and off as required. This contact here, which has the yellow wires, is used to hold the contactor coil in the on position. So essentially the coil in this is 24 volts, and that's activated by a switch on the front panel. But once you actually press that switch, this contact will close, and this will essentially provide power to the contactor's own coil through its own contact, and this is what can hold it in the on position. This is also how the thing can actually be disconnected when there's a power failure, because if power fails, this contact will open, but of course crucially it won't reclose until the coil is energised again using the switch on the front panel. And I have actually done a video on the contactors and this sort of emergency stop arrangement separately, so I'm not going to cover that in any great detail here. And the 4th contact here, which is essentially the auxiliary one on the side, this is coloured grey, and this doesn't have any power connected at all. What this is for is to send a signal to the controller board, and that's the sort of emergency stop signal, as it were, going to the computer. But again, this is just a signal, it doesn't actually have any meaning or operation in terms of the emergency stop itself, so that's actually all done through this contactor. It's just there to send a signal to the computer indicating that some kind of problem has occurred. Now, I saw in the previous segment there the wiring to the contactor, and that's essentially using those 4 separate contacts on the front. So we have the line and neutral for the power, the auxiliary contact on the side, which is just sending a signal to the control board, and then the 3rd one, which was yellow in the previous segment, which is the contact used to supply power to the contactor coil. So in other words, the contactor holds the power on to its own coil, and that's basically how it manages to stay on without any kind of external input to it. Now the circuit we're going to be using is of course 24 volts, so we're going to have plus 24 volts to start with, and from this we're going to have a wire going to the contactor contact, so that's basically a switch there, and from that we're going to have that connected directly to the coil of the contactor, so that when this contact is closed, 24 volts is supplied to the coil, and then of course that will energise and that will hold that contact closed. And in order to actually start this thing, of course this won't close until this is energised, and this won't energise until that's closed. So the button on the front panel is basically in parallel with this, so we've got another switch here, and that simply connects across like that. So this is the contact inside the actual thing itself, and that's basically the button which you press to switch the thing on. So pressing that provides a temporary connection there, coil is energised, coil is therefore energised, this is closed, and that's what holds the contactor in the on position. And for the emergency stop situation, that's basically another switch here, which when it's in the open position like that will disconnect power here, or basically stop the current flowing, coil is de-energised, contact opens, and then it sits there in the sort of open state. And of course we can add several other emergency stop buttons outside the cabinet, which we're going to do at a later time. And the return for these actually just goes back to the negative, or 0 volts for the supply there, so that will basically just loop around like that. So that has to be closed in order for this to work, and then that will keep the contactor in the on position. And when this is opened, coil de-energised, contact opens, and of course power is disconnected to the motors as we would want. Now in terms of the actual contactor, this being the coil, it's a DC coil, so it's going to be positive and negative. Obviously the negative connects to the negative, and positive via those switches or the contact goes to the positive 24 volts. And the particular contact we have has two connections for the coil, and I'll just draw that on the next page. So there's the contactor as we've seen in the control panel, and it has the 4 sets of contacts with the terminals at the top and bottom, so essentially it's 4 of those. And the coil connections are actually on the top here, sort of set back from that, and there's 2 there, and those are positive, negative, and there's also another set on the bottom. Again, these are sort of recessed back from the front panel, and again that's positive and negative, and these are common together, so this one and this one are basically the same, and this one are the same. This happens to be useful in this application because it means we can wire them using both of these rather than having lots of wires all jammed into a single terminal. And the way this is actually implemented in the actual design is that, just use another coloured pen. This is the contact here, which remember was shown in yellow, so that's the one we're using. The other 3 are not relevant to the operation of the contactor. So this is the one which will supply power to the actual contactor coil, so when that's closed it's permanently powered. And in the application we've got here, it's easily achieved by first of all connecting here the positive 24 volts, and then just by putting a link from here to here. So when that's closed, 24 volts goes through this contact here directly to the positive of the coil. Now the emergency stop thing on this is implemented somewhat differently, and this comes off of the negative of the coil, and this actually goes to the emergency stop button, and then say we can have other ones later on, and then eventually this is what goes to the negative of the power supply. And that's pretty much what we had in the diagram previously. So again, the negative of the coil going to the actual contact switches, and then that returns eventually to the negative supply, or the 0 volts for the 24 volt DC supply there. So that's that arrangement there, and essentially then all we need other than that is a way to connect the switch on the front panel, and it just happens that we can actually use these terminals at the top. So in the actual cabinet that we've seen, we've actually got a wire from here to the front panel, and also a wire from here to the front panel, and that's those yellow and grey ones which we've already seen in the previous section. And then additionally to that, we've also got the 24 volts coming in, and that goes to the front panel button as well. So one is permanent power, the other 2 are just the positive and negative for the coil. And this is actually how it's wired up in the cabinet itself, so wires at the top, wires at the bottom, and then of course we've got our mains wires on these 2 here, and then that second contact there is just used to supply a signal to the controller. That's the twin grey wires which come out and go towards the front panel. So the other thing then is the front panel buttons, and we've already seen those in operation, and these are implemented, say, just with the 3 wires here. So there's 2 buttons and obviously a switching part and 2 things which can illuminate, but they can all be powered or operated from just 3 wires. So we've got 3 wires going to that front panel. We've got the coil positive, which obviously comes from the contactor itself. Then we have the plus 24 volt supply, so that's permanently available. And then finally we've got the other coil contact, which is the coil negative. And again, that's directly from the contactor, so 2 from the contactor coil, and then just a single positive 24 volts. Now for the buttons we have, again we've seen those previously, it's just a single contact that we're using. So we've got button number 1, and of course button 2 over there. And in terms of the actual contacts in the button, or the switching part, we've just simply got 2 terminals there, and another 2 terminals there. And then the switching part is obviously between those, well, just rather solid like that. So normally the buttons are open. When you press the button, then it closes those. Those are joined exactly the same over there. And also inside the button, but electrically separate, we have the other 2 terminals, and the same on this one. And between those is actually our indicator lamp. So we'll just draw that as a nasty coil like that. We have of course replaced those with LEDs, but you get the general idea. And of course those are actually green in the case of the ones on the panel. So when we apply power here, then that will light up, and likewise over there. Now let's see how these are actually wired up in practice. Now, first thing we've got is our 24 volt supply. Now, in order to actually do anything, bearing in mind the coil has no power whatsoever to start with, we're going to have to start off with some power going to something. And what we're going to do is take power from the 24 volt supply, and we're going to connect this to one side of the first switch. And we're also going to connect that to one side of the first indicator lamp, or the LED in this case. Now in this case it hasn't actually done anything yet, and in order to actually activate the system we want it so that both buttons are pressed, so this has to be closed and this is closed, and to achieve this we simply wire those two in series, so just put a link between here and there. And of course when we press these, this will then be connected to the 24 volt supply, and this is what we want to switch on the contactor by powering the coil. So from here we're just going to take another wire, and that's the one that actually goes to the positive of the contactor coil. So when one button's pressed, or this one's pressed, nothing happens, but when they're both pressed, 24 volts goes through the switches to the positive of the contactor coil, and then the coil of course will be energized and the contactor will close. Now this lamp over here currently is not connected, and of course we do want that to be connected when the coil is actually powered. So what we can do is connect another wire from here over to the one side of the indicator lamp. So essentially when the button is pressed, or more accurately when the contactor coil is energized with 24 volts, then this lamp will also receive 24 volts here, and once we've connected the other side, that will obviously illuminate as well. Now the only remaining part here is the negative connection for the two lamps, and we're going to use the coil negative in this case, so we're just going to put a wire here, and again link across to the other one over there. So that now we've got a return path for the two indicator lamps. So essentially when this is powered and the coil is energized, 24 volts here, and of course 24 volts here as well, because remember that's permanently powered. And then the coil negative is basically the return, so it just returns via that, as you would expect. However, bearing in mind this is not the negative for the 24 volt supply directly, this actually goes via the emergency stop buttons. So this is only connected to negative when the emergency stop buttons are closed, and this is how we get these to actually light up and do whatever we want. So that if the buttons are all basically in the reset position, so they haven't actually been pressed, this is connected to negative. This lamp here will illuminate because it's got permanent 24 volt power, so that's going to be on and lit up. This one by default will not be, but as soon as you press both buttons, 24 volts is here and here. The coil is energized, and it will stay energized because the negative is connected, and therefore this lamp will then be on because it's receiving the 24 volts via the positive for the coil, and this one was on anyhow because of course the permanent 24 volts is there. So when it's energized, both lamps are on. However, when the emergency stop button is pressed, this basically is broken here, so it's not connected anymore. Both lamps will go out because although they may well be connected at this side, the negative is now disconnected, so there's no current path here. And because the coil negative is now disconnected, the coil won't be operating either, because again, although it may be connected at one side, the negative isn't. So this achieves basically the operation we've seen already, so that with the emergency stop buttons pressed, or one of them pressed, neither lamp will operate, and if the coil was energized, well, it's not energized anymore because that's disconnected. Once this is reconnected, this lamp will illuminate due to the permanent 24 volt supply here. This one will not. And then when you press both buttons, the coil is energized via the switches. And because this is also connected, this will illuminate, and the coil will also be energized. And then, of course, due to that diagram we saw on the previous page, the contact inside will close, joining these two together, and then it will stay on. These will stay on, and the contactor remains closed until this is broken by pressing the emergency stop. So that's how that is implemented, and so it only requires 3 wires from the contactor and the supply, and that achieves all of the functionality that we wanted here. And the final point then is the button 1 is the one on the panel which is marked E-stop reset, and the other one here is marked motor power. And it's necessary to press both of those to start. So E-stop reset lights up when the E-stops have been reset to the normal position, and of course motor power illuminates when the 48 volt supply and the spindled inverter have power. So that's it for this time. And in a future episode, of course, we'll look at putting the motors and things in and wiring those into the control cabinet. And the final point about this arrangement is that the emergency stop system we've got here is completely separate from the electronics and the controller, purely relies on that contactor. It isn't just a question of sending an emergency stop signal to the computer and then hoping it's actually going to turn things off, because of course it may not. This actually just cuts the power to the motors, and then it does also send a signal to the computer advising of this fact. And then there's a fairly important distinction between those two. So until next time, thanks for watching.